Okay, so you see, today discuss already I have sent. Question is maximize z equal to 6x1 minus 4x2 such that twice x1 plus 4x2 less than or equal to 4, and the next constant is 4x1 plus 8x2 greater than or equal to 16, and x1 comma x2 greater than or equal to 0. So you see here what is objective function? What? Anybody?
6x1 minus 4x2.
So this is the maximization problem. Okay. So first what is our aim? Our aim to first all constraint sign should be equal to sign. So our constraints are what? Plus 4x2 less than or equal to 4. All of you see, our first constraint is what? Twice x1 plus 4x2 twice x1 plus 4x2 equal to 4. Then how can you get the straight line from this equation, Roshni?
Yes, sir, 1 minute. Sir, by taking the equation plus x1 plus 4x2 equal to 4, and then by putting x1 equal to 0, we will get the value of x2, and then x2 equal to 0, we will get the value of x1.
The value of x1. Okay. So clear everyone? Arbaj, Asif?
Yes, sir.
Yes, sir.
Okay. So from the so from this you put x1 equal to 0, then you get the value of x2, x2 equal to 0, you will get the value of x1. Okay, so then you will calculate and you will see, you will get one coordinate be, it will be here. This one will be 2 comma 0, and another coordinate will be 0 comma 1. So 2 comma 0 and 0 comma 1. So you can mark this one in the diagram. You can also mark this one, say 2 comma 0 and then 0 comma 1. Okay. So next one is what? From this line, what will be which region we shall shade? Means which one shaded? From line we shaded origin containing side or line from away this side?
Sir, the origin containing site.
Yes, this is origin contain. Why?
So because it satisfies the
The
uh,
inequality. Yes, good.
inequality.
Because when we substitute 0 0, then it satisfies the inequality. So 0 0 then satisfies inequality. So this is origin containing site. Next one, next inequality is 4x1 plus 8x2 greater than or equal to 16. So similar way, we make it equality, means equal to sign, then we get a straight line. And again you substitute x2 equal to 0, then you will get the x1 value, means one coordinate. So coordinate will be 4 comma 0, and another one, when x1 equal to 0, then you will get 0 comma 2, 4 comma 0 and 0 comma 2 you will get. So next you check, this one will be what region we consider, which side region will be, in which side you will consider.
Outward
Region will be
origin.
from, yes, 0 0 substitute, then you see 0 greater than or equal to 16. So this does not satisfies the inequality. So from line to away, this side means what, not origin containing side. Line from out of the above the line, we consider the shaded one will be line from the above. Okay, so next you see, from this can we get the solution from this two inequality, from this constraint, can we get the solution?
No, sir, there is no common region,
Common region, yes, common region is called what?
feasible region.
Yes, so there is no feasible region. Okay, so if there is no feasible region means what, this the inequality, this we cannot get the solution. Feasible region is also called the feasible solution space. Okay, then we cannot get the value of x1 and x2. So this problem conflict this constraint. So you see the language I have written in this way. The constraints are plotted on the on graph as usual as shown in the figure. So you can calculate here and find out the coordinate a, b and c, d. For inequality, first inequality you will get two coordinates. For the second inequality you will get the another two coordinates. Okay, so from these coordinates you can find out, and then you can write the constants are plotted as on graph as usual as shown in figure. There is no unique feasible solution space to get unique set of values of variable x1 and x2 that satisfies all the constant. Here there is no feasible solution to this problem because of conflicting constant. So we cannot get here solution. Okay, no feasible solution of this problem. So this is the problem. Clear, Shudip?
Yes, sir.
Pradhanna?
Yes, sir.
So you see, in this way sometime given whether can we get the feasible solution or not. Okay. Next question you see, use the graphical method to solve the following linear programming problem. So here graphical method is what? Here maximize z equal to 3x1 plus 4x2 subject to the constraint x1 minus x2 greater than or equal to minus 1 and minus x1 plus x2 less than or equal to 0 and x1 comma x2 greater than or equal to 0. So you see, first our problem objective function is maximization problem. So you'll remember this is the maximization problem. Next one is what? First you see the constraint x1 minus x2 greater than or equal to minus 1. So from this inequality, first you make it equality and then we get two coordinates and we get a straight line. So similarly you put x2 equal to 0, x1 is minus 1. So 0 and minus 1 is one coordinate. 0 and minus 1 will be 0, yes, 0 and minus 1 will be one coordinate. Yes, 0 minus 1 will be one coordinate and another one will be, you see here, when x1 is 0, x2 is 1. So 0 and 1 is another coordinate. So one coordinate will be minus 1 0, and another coordinate will be minus 1 0, another coordinate will be 0 1. So from here you see, you draw a straight line. So negative 1 we will not draw the line. So from only first quadrant, the line always lies in the first quadrant. Why? Because x1 and x2 greater than or equal to 0. Only consider the positive one for the x1 and x2 x1 and x2 axis. So next constant is minus x1 plus x2 less than or equal to 0. Minus x1 plus x2 less than or equal to 0. So minus x1 plus x2 less than or equal to 0. Then line will be what? How to draw the line? Ripon? Minus x1 plus x2 less than or equal to 0. So how to draw the line?
Sir, x1 equal to x2.
Uh, x1 equal to x2. Okay, then line will be what?
Sir, straight line
Yes, good. Straight line.
মানে passing through origin.
Straight. Yes, good. So you see, minus x1 plus x2 if less than or equal to 0 means you make it equality. So minus x1 plus x2 equal to 0, then you write x2 equal to x1 or x1 equal to x2. No problem. Then you see, this is y equal to mx format. Y equal to, here our axis is x1 and x2, and if you consider x and y axis, then x1 is x-axis, x2 will be y-axis. So standard formula in the coordinate geometry for equation of a straight line passing through origin is what? Y equal to mx. So here you see, x2 equal to x1 if consider, then x2 is y, x1 is x. So y equal to x. Our aim is 1. So y equal to mx format. So y equal to mx means what? Equation of a straight line passing through origin. Clear? So you see this line passing through origin we have drawn. Next, this one here, gradient means m is 1 means what? This makes an angle with x on x is 45 degree. So using this makes an 45 degree because each quadrant angle is 90 degrees. So this 45 degree. So here you see, next our aim is what? Our aim is find out whether can we get the feasible region or not. If we do not get the feasible region is called the common region. If we do not get the feasible region, then we cannot get the solution. So first you check whether can we get the feasible region. So first you substitute in the first constraint x1 0, x2 0. So 0 greater than or equal to minus 1. So satisfy. So from this line to origin containing side. Again, you substitute 0, 0 in the second constraint, also satisfies, then this is origin containing side. So, feasible region I have shaded here. So, this is the shaded. And you see, this is feasible region we already got, but this is bounded or unbounded?
Unbounded.
Yes, unbounded. You see, this is unbounded because you see, in the right hand side region, all the feasible means all the points satisfies, means if you substitute x1 and x2 any value, then this lies in the feasible region and there is no restriction, there is no boundary. Okay, so this gives us an unbounded solution. So you see, we have written in this way. Plot on the graph each constant by first treating it as a linear equation in the same way as described earlier. So you can write not earlier, just you show this coordinate you can find out. Then use inequality condition each constant and mark the feasible region shown in the figure. So you see we have marked the feasible region. Then it may be noted that there exists an infinite number of points in the convex region for which the value of objective function increase as we move extreme point means origin to the right means right side. That is, both the variable of x1 and x2 can be made arbitrarily large and value of objective function z is also increased. So this thus the problem has an unbounded solution. Means what? You see the shape and you can put the value of x1 is suppose 2 and 1, then this 2 comma 1 also lies in the feasible region, then 3 comma 1 also lies in the feasible region, 4 comma 1 also lies in the feasible region. So when we substitute this value means 2 comma 1, 3 comma 1, 4 comma 1 in z function, then you see 2 comma 1, then z value will be 6 plus 4 means what? 10. Then 3 comma 1 means what? 9 plus 4 is 13. Then 4 comma 1 means what? 12 plus 4 is 16. So you see z value is gradually increasing and all the point lies in the feasible region means x. So for these values of x1 x2 this satisfies. So we cannot say that what will be the value of z at particular point. So this is increases arbitrarily. So that type of problem we can say that this gives us an unbounded solution. Clear, Bhargav?
Yes, sir.
Dipanshu?
Yes, sir.
Dipanshu? Okay. So you see the language, this one, and compare with the graph, then you can easily write this one. Just first you find out what are the points. For the constant, first constraint, what is the point? And always you will see, always graph lies in the first quadrant. And sometimes someone asks why always the graph lies in the first quadrant, then you will see here in condition given always x1 comma x2 greater than or equal to 0 means x1 positive, x2 is also positive. So in which quadrant? Both the x1 and x2 positive, in the first quadrant x1 and x2 positive. So for this region, this always graph lies in the diagram, graph lies in the straight line lies in the first quadrant. So you see this is the problem of unbounded solution. So next one will be what? Next one will be here. Suppose more than one variable is given in the linear program, more than two variable is given in the linear programming problem, then how to solve the problem? So we already earlier I have discussed if more than two variable are present, then how to solve the linear programming problem. So you see more than two variable till now, I have discussed about linear programming problem contains up to two variable. If more than two variables are present, then we cannot solve it by graphical method. So this is one of the disadvantage of graphical method. So sometime ask question, write the disadvantage of graphical method. Okay, so you write the disadvantage of graphical method, then you can write this point. If more than two variables are present in the linear programming problem, then we cannot solve it by graphically. So this is the one of the disadvantage. So for more than two variable, we have another method. This is called algebraic method and known as simplex method. So you find out what is simplex method. All of you find out simplex method. Heading is simplex method. Okay. So you see, we have learned to solve linear programming problems involving two variables x and y graphically. A linear programming problem involving more than two variables can be solved by algebraic method. This method is known as simplex method. So sometime define simplex method, sometime ask. And for simplex method, we need some variable. Oh, so first one is called the select variable. What do you mean by select variable? Because you see, in graphical method, what we do in constraint, suppose less than or greater than or equal to given, then quickly what we do, we make it equality. When we make it equality, then this is a straight line because this is two dimensional. So this is straight line equation. So straight line equation, how we shall get one straight line? Minimum we need 2 points. So considering one variable 0, we get another variable means one coordinate, and for getting another coordinates, another variable 0, then we get the other variable. So in this way we find out. But in simplex method, this is what more than two variables. So this is not in two dimensional. This is either 3, 4, 5 dimensional problem. So what we do for this reason, here we require some special variables. So first one is called the select variable. So what does it mean? Select variable. Select variable means what? If a constant has a sign less than or equal to, means constant sign first you check here. In simplex method, first you check what are the sign of the constants. If sign of the constant is less than or equal to, then in order to make it equality, we have to add something positive to the left hand side. Okay, something positive to the left hand side. The positive variables which are added to left hand side to the constraint to convert them into equalities are called select variables. Means what? Suppose left hand side is, suppose x1 plus x2 less than or equal to 2. x1 plus x2 less than or equal to 2. All of you write, suppose x1 plus x2 less than or equal to 2. So which side is greater?
The right hand side.
Right hand side is greater. So if right hand side is greater, then what we do? Our aim is equality. So then we add something positive to the left hand side. So x1 plus x2 plus suppose one variable, say s1. Say s1 variable we add. So s1 variable add, then equal to we write 2. Means what? Suppose 2 less than or equal to 4. Okay. So when this make is equality, 4 equal to 4. So 2 less than or equal to 4. So in the left hand side, we require how much value? another value 2, so plus 2. These two we denoted by, we don't know what is the value, so we write this is S1. For the first equation we write S1. S means select, 1 means for the first equation. Sometime written S2, S means select variable, 2 means for the second constant. So S1, S2, S3, in this way we shall write. So here you see one example I have given, max z equal to twice x1 plus 3x2 plus 4x3, such that x1 plus x2 plus x3 less than or equal to b1, twice x1 plus 4x2 minus x3 less than or equal to b2. So in order to convert these constraints 1 into equalities, we add, so here I have written x4 and x5. So for the first constraint, x1 plus x2 plus x3 plus x4 I have written. X4 means slack variable. In place of x4, you write s1, then equal to b1. Next constant is twice x1 plus 4x2 minus x3. Then you write plus s2. Then this is less than or equal, then this is equal to b2. Then s1 and s2 are called the slack variable. You can give any names, either x4, x5 or s1, s2 or w1, w2, anything. But remember, this is called the slack variable. So you see, slack variable is clear or not?
Yes, sir.
And one thing you see in this example, right hand side maximum objective function is max z, and constraint right hand sides are what? Constraint right hand side, Arbaj? Constraint or right hand side to কি আছে?
Sir?
Variable or যোনটো example to চোৱা, example to max z equal to আছে twice x1 plus 3x2 plus 4x3 আৰু constant কেইটা পাইছানে চোৱাচোন.
Yes, sir.
So constant right hand side is what? First constant right hand side is
B1.
b1 and second constant right hand side is
B2.
b2. So all of you see this b1 and b2 always positive. This b1 and b2 should be always positive. If negative, then we make it into the positive. Clear? So for simplex method, for solving linear programming problem using by simplex method, always you will remember right hand side all bi's. Bi's mean b1 and b2, another equation is given, then b3. So for this reason I call this is bi's. So all b1 b2 should be positive. But in graphical method, no problem. If negative, no problem. But simplex method, always b1 and b2 should be positive. And if any b1 or b2 is negative, then your duty is first we make it into positive, then we use which variable we introduce, slack variable or surplus variable. Clear this one? This is one of the important note. You see,
Yes,
this is
sir.
clear or not? Okay.
Yes,
Acha,
sir.
suppose x. Okay. So suppose write just one inequation. Just you write x1
Sir,
minus x. Yes.
sir, if the constraint has sign greater than equal to, then we will
Mm.
add something positive to the right hand side.
No, no. Always we shall means add always if something positive in the left hand side. But when greater than or equal to symbol is present, then here we will not use here slack variable. Then we use here another variable. Then this is called the surplus variable. Then we subtract something positive.
Okay.
Clear? So next definition I shall discuss means when we apply surplus variable. Okay,
Okay,
good
sir.
question. Yes. So you see when greater than here next discuss means greater than or equal to symbol is present, then here we cannot always we should means add or something positive we add or something positive we subtract always in the left hand side. Okay, so if greater than or equal to symbol is present, then we cannot add in the left hand side, then we subtract something positive to the left hand side, then balance. Okay, so you write one inequality, say x1 minus x2. All of you write x1 minus x2 plus x3 greater than or equal to minus 1. x1 minus x2 plus x3 greater than or equal to minus 1. So when we solve, because you see this inequality, for solving this problem we use here simplex method. So first, making equality sign, what we check, what is our bi here, what is our bi?
-1.
Minus 1. So this is positive or negative? Negative. Huh? So first, what is our duty?
Making
To
it
make it
positive.
Yes, good. Make it positive. So how to make it positive?
By multiplying both side by minus.
Minus 1. Good. So next you see our aim is check whether all bi should be positive. So immediately multiplying both side by minus 1. So all positive sign will be negative. So you see minus x1 plus x2 minus x3 less than or equal to 1. So next you add here slack variable. Clear? So you see this is clear.
Yes, sir.
Yes, sir.
Okay. Binoy.
Yes, sir.
Okay. Arif.
Yes, sir.
So all of you see if any doubt you can ask, and all of you write this one. From here you make copy and write all these things. So up to this you see next class I shall discuss if greater than or equal to symbol is present, then what we do. So here already asked question, Rosne asked the question, greater than or equal to symbol is present in the constraint, then we apply here surplus variable. Anything, Dipanshu?
Present, sir.
Okay, you see just response your name, Oboni.